So yesterday we did Half-Life, and then you had a little bit of homework. I wasn't sure if you were gonna be ready for the homework, to be honest. So this is kind of a good gauge on how much you understood Half-Life. So first of all, over here, it says the table to the right gives information about the radioactive decay of carbon-14. Part of the table has been left blank. Fill in each of the blank spaces with the answers to the, so fill in each of the blank spaces and answer the following questions. So they gave you some blanks there, and they did ask you to fill them in. That was part of the question. So as you see here, it's very similar to the work we did yesterday with the Twizzlers. After 0 half-lives, we have a whole, now this is a gram, but we have a whole gram, and that took 0 years to get to a whole gram. Then after 1 half-life, we're down to half that gram, and it took 5,700 years. 2 half-lives, we're at a quarter, and it takes 11,400. 3 half-lives, we're down to an eighth. It takes 17,100. Now this should be seeming familiar. Like we did yesterday, we started with a whole, we went to a half, a quarter, and then an eighth. Now we did it with Twizzlers, so each one of those took 30 seconds, but what did we decide, or what did we talk about yesterday? Does it matter what radioactive element we use? No. Okay, so some of you are shaking your head no. It doesn't matter what radioactive element we're using. It'll always go from a whole to a half, to a quarter, to an eighth, to a 16th. The only thing that changes is how long that takes. Twizzlers only took 30 seconds. Carbon-14 takes 5,700 years. So how did we finish this table? What's the fraction left of that 1 gram after 4 half-lives? Drake? Not 1/10, no. How do we cut a fraction in half? What do you gonna do with a fraction? You are gonna divide, so you take 1/8 and divide it by 2, and I'm not good with fractions, but I can tell you when you divide by 2, you double the denominator. So it goes from 1/8 to 1/16 to 1/32 to 1/64. Again, if you're not good with math, please don't let that be what messes you up. You just double the denominator. 8 times 2 is 16. 16 times 2 is 32, times 2 is 64. So that's where those numbers came in. So if you don't have that table filled in, please do so now. Now, where does the number of years come from? We started at 0, then 5,700. Where's that 5,700 coming from? Yeah. Yeah, and then you just keep adding it. Good. So 1 half-life is 5.7 times 10 to the third. If you forgot, that's 5.7. You move the decimal point over 3 spots. 1, 2, 3. This is 5,700 years. And like Trenton said, you just keep adding that on. So 5,700, 0 plus 5,700, oh my goodness, 0 plus 5,700 gives you 5,700. Then 5,700 plus another 5,700 gives you 11,400. That's where that came from. Plus another 5,700. That's 17,100. Just keep adding 5,700. 22,800 plus 5,700. 28,500 plus 5,700, 34,200. So that's where those numbers came from. Now we can finally answer the questions. The first one says, what is the percentage of original carbon-14 remaining after 2 half-lives? What did you get for that? Almost all of you did your homework. Allison, what did you get for after 2 half-lives? You're not wrong. It is 1/4. But what about saying 1/4 makes me have to mark this wrong? Trying to find it, huh? Yeah, it does say percentage. So you have the right number, you know what you're doing, but this is where the Regents is going to nail you. If they ask for a percentage, we can't give a quarter. So a quarter is a fraction, not a percentage. So make sure you answer the question they asked. So the next one says, what is the percentage of decay product? Before we do this, what the heck is a decay product? Okay, so what the radioactive isotope turns into. So yesterday, our Twizzlers have turned into poop. That was their decay product. By the way, what is the decay product of carbon-14? Do you know, Phoenix? What's the decay product of carbon-14? Does that seem like a question you need to know off the top of your head? No, so what should you do? Front page of your reference table, everybody find it. Unless you know the answer, please look it up. What is the decay product of carbon-14? So it's what carbon-14 turns into. You see it up there in that chart? I'll put, what's it say? Yep, 14C turns into what? 14N. That means nitrogen 14, but you don't have to know that off the top of your head. So your answer could be, oh wait, that actually wasn't the question. So it says, what is the percentage of decay product after 3 half-lives? So yeah, so I've been kind of generous on it. More than half of you have AirPods in. Take them out now, or I'm going to start taking them at the beginning of class. So all of you with AirPods in, you see it in there. Thanks for wearing your hair up. I know you're not horrible people for trying to tune me out. I get it. My own daughter does it to me. And she does it in school. She chooses her hairstyle based on how bored she plans on being that day. But don't do it here anymore. It's insulting. Anyway, decay product after 3 half-lives. Does this chart tell us that? It does not. So what do we gotta do about that? How do we figure out the decay product? No. So let's look at these. Maybe this will help. How much decay product do we have when there's 100%? In fact, let's go here. Everybody go to page 8. Did you all do yours in red yesterday? So page 8, your circles are in red. Let's write the decay product in blue. If we have 100% Twizzler, how much poop did we have yesterday? 0%. Do you guys not want to write poop? Are you too cool for that? Okay, so then we'll write decay. No, so I'll just do decay product. No. So if we have 100% Twizzler, we have 0% decay product. If you have 50% Twizzler, how much decay product did we have? The other half is the decay product. So this one is 50% decay product. If we have 25% Twizzler, how much decay product did we have? 75. By the way, how did you figure out 75? 100 minus 25, and most of you can do that math in your head. How many of you can figure out the next one in your head? Because I struggled. It is 87.5, but in case you want to figure it out, you take 100 minus whatever's there, so 12.5 gives you that 87.5%. So how do I figure out the next decay product for when we have 6.25%? What do I have to do? Same thing, 100 minus 6.25. That's 93.75% decay. Now this was for the Twizzler. Will this look any different for carbon-14? No, so not only does the Twizzler behave the same way, like the original Twizzler and the original carbon-14 behave the same way, but so does the decay product. So what about for uranium-238? Well, how's this gonna look? The same. So they did ask after 3 bites. After 3 half-lives, we had 12.5% carbon-14. That will leave us with 87.5% decay product. And again, it didn't ask, but that will be nitrogen-14, like Phoenix said about half an hour ago. Finally, as the amount of decay product increases, what happens to the original isotope? So as the Twizzler went away, what happened to the poop? It came out, yeah, there was more. Okay, so as the original isotope, so let me read this again. Sorry, as the amount of decay product increases, so I'm sorry, I read this wrong. As the amount of decay product increases, what happens to the original isotope? Yeah, it goes down, it decreases. Hey guys, does this graph look familiar? Kind of, why does this graph look familiar? It is exponential. It should kind of look familiar from math, but it should also look familiar from the graph we drew yesterday. Here's that graph we drew yesterday. See how it goes down and then does not touch 0? Where'd that other line come from? The one that's going up? Where'd this line come from? That's the decay product. So again, as the Twizzler went down, the poop went up. This asks for the half-life. How can I figure out how long the half-life is from looking at this graph? What is the definition of half-life?
Oh.
What about half? How long it takes to get to half? So 50%, half. How long does it take to get to 50% according to this graph? Okay, 5 times 10 to the third. Is that 5,000 or 50,000? I heard some people fell for it. That's 5,000. See how they try to mess with you? What? Okay. Ooh, and one last question before the end. We'll get to the last one tomorrow. Which one of these is the oldest? Why did you say 1? Because there's only 10% left. Guys, I hope you saw on the board your homework is page 12. There's 4 more, or it might actually only be 3. Oh no, there's 5 more Regents questions on page 12 for homework.